Hello, my dear students. Today again we will discuss chapter number 11, alcohols, phenols and ethers, and the topic will be our second type of chemical reactions. Chemical reactions of alcohols. Okay. Type 2 we are going to discuss, which is cleavage of CO bond. Okay. And the first type of reactions we have already discussed, which was cleavage of OH bond, right? In the last video, I have discussed with you the cleavage of OH bond. In this, I will discuss the cleavage of CO bond. And in this, there are three categories that we are going to discuss. A is reactions with hydrogen halides, B is dehydration, and C is oxidation. Okay. Now here one thing you need to remember that this cleavage of CO bond, in this the alcohols act as electrophiles. Now if you have seen the last video, you will understand this meaning that in type 1 reactions they act as nucleophile, and in this type of reactions they act as electrophiles. And also this type of reaction is shown by only alcohols. Phenols show this type of reaction only with zinc. Okay, it is given in your NCERT also that phenols show this type of reaction only with zinc to give benzene. Now the question comes, why phenol do not show this type of reaction? So you will write down due to partial double bond character. Here we have already discussed that this is phenol, okay, OH. This bond has partial double bond character, so it is difficult to break this bond. Okay. So let's start up with our first type of reaction. Okay. Reaction with hydrogen halides. Okay. Reactions involving cleavage of carbon-oxygen bond, and our first A part we are going to do reaction with hydrogen halides. Now see, alcohols react with hydrogen halides to form alkyl halides. Now alkyl halides, so we have studied this reaction in our last chapter. Okay, so what we have taken? We have taken alcohol here, ROH plus alkyl halide, any alkyl halide we can take, and the product is, this is what, alkyl halide plus water is eliminated. Okay, now if we take consider one particular reaction, see, if we use Lucas reagent, okay, I have already discussed this reaction. Let me discuss this again. Lucas reagent. This is very important reaction which is used to distinguish between 1 degree, 2 degree and 3 degree alcohols. Okay, this is known as Lucas test also. Lucas test. And it is used to distinguish between 1 degree, 2 degree and 3 degree alcohol. Now what is Lucas reagent? Conc HCl plus anhydrous ZnCl2 is known as Lucas reagent. Okay. Now if we take a 3 degree alcohol, suppose I take 3 degree alcohol, then what will happen? The product formed, which is Rx, okay, product formed will be Rx, and since it is immiscible, so turbidity will be obtained immediately for 3 degree alcohol. Okay, turbidity. Since the product formed alkyl halide is immiscible, so it will form a precipitate and turbidity will appear immediately. But for a 2 degree alcohol, you need to write turbidity will be obtained in 5 minutes. Okay. But for 1 degree alcohol, there will be no turbidity at room temperature. At room temperature, there will be no turbidity. Okay. So you need to remember that this test, Lucas test, is used to distinguish between 1 degree, 2 degree and 3 degree alcohol. 3 degree alcohol will give turbidity immediately. Okay, immediately. 2 degree turbidity after 5 minutes. 1 degree no turbidity at room temperature. Now one more question that can arise is, why 3 degree alcohol give turbidity immediately? See students, this reaction takes place with the formation of carbocation and it will follow SN1 mechanism. All these things we have studied in haloalkanes. So if you have not seen the video, go through it so that these concepts are clear to you. So this reaction follows SN1 mechanism and proceeds with the formation of carbocation, and you know that 3 degree carbocation is the most stable due to, yes, plus I effect of, due to plus I effect of alkyl group. Okay. So the order of reactivity is 3 degree, 2 degree and 1 degree. So this was just a repetition of the reaction that we have studied in our last chapter. Okay. Now let us see our next reaction, which is dehydration reaction. Okay. Our next reaction is dehydration reaction. Before starting the reaction, I will tell you that there is mechanism in this reaction. And if we talk about the chapter, then this is our second mechanism. Okay. First mechanism we have already discussed. This is our second mechanism. So any of the mechanism can come in your exam, board exam. Now see, alcohols undergo dehydration to form alkenes on treating with protic acid. Example, Conc H2SO4. Okay. So here what it should be there, H plus should be written here. Okay. This is an alcohol. What will happen? This will be eliminated as water, and what we will get? We will get an alkene here. And if you recall, opposite of this reaction we studied, and the mechanism was there in that reaction, acid hydration reaction. Okay, it is there in the last video. Now talking about this reaction, see, you can see it clearly. Alcohol undergoes dehydration. Dehydration means what? D word stands for removal. Okay, removal. Here what is there? Removal of water is known as dehydration. To get an alkene is known as dehydration of alcohol to get alkene. Right? See students, now this is as given in NCERT. See, we have discussed this reaction now. C2H5OH and CH2SO4 and 443 Kelvin is written. Okay. Now one thing, this is what? 1 degree alcohol. And here we are getting the alkene, which is ethene plus water. You need to remember this temperature. Why? Because if the temperature changes, then the reaction taking place will be different, and that you will study further. Okay, this was 1 degree. Now secondary and tertiary alcohol are dehydrated under milder conditions. Okay, as it is clear by the reaction given here. This is what? 2-degree alcohol. Why? Which group is present? CHOH. And see, the reaction conditions are milder than this one. Now, if there is a 3-degree alcohol, okay, now if you compare the reaction conditions, it will become more milder to get the product. Now, why this is so? Again, the answer comes same, that see, you can predict. Here, what I have told you, 3-degree reacts more easily than 2-degree, than 1-degree. Why? Since this reaction proceeds with the formation of carbocation. Okay. Okay. See, again I am telling you the same thing for dehydration also. For dehydration also, if we talk about the order of alcohols, then 3-degree, then 2-degree, and then 1-degree. Why this is so? Because due to the formation of carbocation as the intermediate. Carbocation as the intermediate, and we know that 3-degree carbocation is more stable among 2-degree and 1-degree carbocation. Okay. Now let us look into the mechanism of this reaction. This is what? Mechanism. It is given in your NCERT also, and very important, you need to remember all these 3 steps. Okay, it involves 3 steps. Right, children? See the first step. This is step number 1, which is formation of protonated alcohol. See here, oxygen has lone pair of electrons. This lone pair will attack on H plus to form protonated alcohol. This is known as protonated alcohol. And in second step, what will happen? Here, see, this will remove as water and we will get carbocation. Now, why this happens? Because here the oxygen carries a positive charge which is very unstable. So, what will happen? This will remove as H2O and we will get carbocation. Now, this is step number 3. What will happen here? Formation of the final product ethene by elimination of a proton. Okay. This H will give its electron and come out. This H will give its electron and come out. So here what will be formed? Double bond will be formed between these 2 carbons. So the final product is ethene. So this mechanism also, like the last mechanism, involves 3 steps. First, second and third. You need to remember these steps as it is, as given in your NCERT, and when you write the mechanism in your board exam, then you need to show these arrows also. Very, very important. Fine. So this is very important mechanism and a direct question comes from this mechanism. Now let's move on to our third and last type of reaction, which is oxidation. This is our C part. See, oxidation of alcohol involves the formation of carbon-oxygen double bond with cleavage of OH and CH bond. These are also known as dehydrogenation reactions, as these involve loss of dihydrogen. So, if I talk about only this term, it is known as dehydrogenation, which means removal of or loss of dihydrogen first of all. Now see, this is an alcohol. Okay. Now this bond will also break up and this bond will also break up. Now what will happen here? A double bond will be established here. See, the example is given RCH2OH. Okay, this hydrogen and this hydrogen will be eliminated. And what will happen? RCHO will be formed. RCHO. And you know which functional group it is? It is aldehydic group. Okay. So oxidation is also known as dehydrogenation because it involves loss of dihydrogen H2. Now let us study this oxidation in detail. See, this is the same thing. Bond breaking, again it is shown, and the formation of C double bond O bond. Now see, this I have taken from your NCERT. See, these reactions I have taken what are given in NCERT. This RCH2OH. Now you can identify this is 1 degree alcohol. On oxidation gives aldehyde first and further on oxidation gives carboxylic acid. Okay. Now if you compare the number of carbon atoms in the starting and the final product are same. So what we can say that 1 degree alcohol on oxidation gives aldehyde, which on further oxidation gives acid with same number of carbon atom. Okay, this is for 1 degree alcohol. Now see, here the reagent is changing. This CrO3 is known as chromic anhydride. Now if we use this reagent, then we can stop the oxidation till aldehydic part. And if we take any of the strong oxidizing agents, which is K2Cr2O7, K2Cr2O7 in acidic medium, potassium dichromate, or if we take potassium permanganate, okay, so oxidation will not stop here till aldehydic part, it will go till carboxylic acid. But if we take CrO3, we can stop the oxidation till aldehydic part. Okay, so this CrO3 is used as an oxidizing agent for isolation of only aldehydes. Now if you see this, PCC is written in the third reaction. Okay, PCC stands for pyridinium chlorochromate. PCC stands for pyridinium. Again, very important reagent. It is given in NCERT. Chlorochromate. Okay, pyridinium chlorochromate. Again, the alcohol is what? 1 degree alcohol. And see, the final product is still aldehyde. Okay, aldehyde. And one more thing you can observe here is that here double bond is also there, but it remains intact in the final product. So we can use PCC and can get aldehyde, and also if there is any double bond, then it will remain unaffected. Right? See, all these reactions are given in NCERT also. You need to remember, if we use a strong oxidizing agent, first we will get aldehyde and then finally it will give acid. But if we use CrO3, we can get only aldehyde. With PCC, we can get only aldehyde, but there is one more advantage, this double bond will remain unaffected. Okay, now see, if you see this is what? 2 degree alcohol, and what we are taking? CrO3. I told you CrO3 is known as chromic anhydride. So in case of 2 degree alcohol, ketones are formed, and its further oxidation is very difficult and takes place in very vigorous condition. Okay, so what you need to remember? See children, 1 degree alcohol, if there is strong oxidizing agent, we get aldehyde and then acid. with same number of carbon atom. 2 degree alcohol, what they give? They are oxidized to ketones. Further oxidation is very difficult. Okay, and 3 degree alcohols also undergo oxidation under vigorous conditions. Okay, they need very strong oxidizing agents and very elevated temperatures. Fine. So for normal conditions it is not possible. So this was all the 3 types of alcohols, and 2 more reagents you need to remember. One is CrO3 to get till aldehyde. One is PCC, which is pyridinium chlorochromate to get aldehyde, and if there is double bond in the reactant it will remain unaffected. Right. Now let us see one more thing. See this term, dehydrogenation. Dehydrogenation. And one more thing, we can in fact write it as catalytic dehydrogenation. Catalytic this should be hydrogenation. See, when vapors of primary and secondary alcohol are passed over copper at 573 Kelvin, dehydrogenation takes place and an aldehyde or ketone is formed while tertiary alcohol undergo dehydration. Now what is this? See, in all the cases, first of all, let us see the reagent is Cu 573 Kelvin, Cu 573 Kelvin, Cu 573 Kelvin, and this is what 1 degree alcohol, 2 degree alcohol, and this is 3 degree alcohol. See, 1 degree alcohol will undergo dehydrogenation. Again, you all know what is dehydrogenation? Removal of H2. These two reactions are removal of H2. Okay, see carefully. Here what will happen? This one H and this H will be removed and the final product will be aldehyde. Okay, and this is what 2 degree alcohol. In this also these two H will remove and the final product will be a ketone. And this is what 3 degree alcohol. In this what will happen? Dehydration will happen. Okay, dehydration. This is the difference. First two are dehydrogenation, but this is dehydration. And you know what is dehydration? Removal of water. So this will remove and we will get alkene. Okay. Now the question arises, why this 3 degree alcohol forms an alkene? Because the reason is 3 degree alcohol does not have any alpha hydrogen. It does not have any alpha hydrogen. This is just for your knowledge. You need to remember these 3 reactions. Right? So this was in your oxidation. Okay? Itself. Okay children, so we have covered type 2 reaction, cleavage of CO bond. A part, reaction with hydrogen halides. One important test is here, which is Lucas test. Second, dehydration. What is important here? Mechanism is there. Third is oxidation. What is the use of this reaction? This reaction is used in conversions again and again. And I have discussed with you all the conditions, all the reagents with you. Okay, so go through your NCERT also. All these things are there and learn them properly. Thanks for watching this video.